So now we are going to solve the C problem of Codeforces round 826 div 3. So the given problem is you are given a sequence A consisting of n positive integer. Let's call a group of consecutive elements a segment. Each segment is characterized by two indices. The index of its left and the index of its right hand denoted by A, L, comma R, and segment of the sequence A with the left end in N and the right end in R. AL comma R equal to AL to AR. For example, if A equal to 31 4 this, then A 2 comma 5 equal to 2 to 5 this, and A 5 comma 5 equal to 5 to 5 this, and if 1 comma 6 equal to 1 comma 6 this to this. So this is the at the segment we split the given sequence A into segments so that each element is in exactly one segment. Okay, each element exactly in one segment. Okay, the sums of the elements for all segments are equal. Okay, sums have to be equal, like 1 comma 2 5 comma 5, the sum is equal 3 comma 5, the sum and this sum are all are 100, so this is equal. Each element belong to exactly segment. The sum of element of the each segment is 100. Let's define thickness of a split, the length of the longest segment. Okay, for example, the thickness of the split from the example above is 3 because the longest segment with the same sum of all segment is a 3. Okay, find out the minimum thickness among all possible split of the given sequence of A into segment in the required way. Okay, then we are given T, then N, the length of the sequence, then N elements, and we have to just output one integer, the minimum possible thickness of a split. Okay, not there are always exist, like you can always consider whole sequence as one. Okay, if there are no split are available, then we can just consider a whole sequence as the answer. Okay, so let's break down the test cases. So here we are given this segment. We can uh, split the segment, first segment like this. We can just split the segment this way. The second one, there is no split available. We can take the 4, so the maximum thickness will be 4. Where the maximum thickness will be 3. And for the fourth test case, sorry, first, second, third. For the third test case, if we take the first two, then the second, then the third, and all are 65, then the maximum thickness is 2. And if we take, we can take it in two ways, like if we take first one and then 4 and then this, the maximum thickness will be 4 because the sum of all segment are same, but the length of the maximum segment is 4. We can take it in other way, that if we take this one and the other half one, we can also have the same segment with a minimum thickness 3. Okay, so now let's understand how can we implement this. How will be the what will be the approach of the solution of this particular question. So to understand, let's take the first example. So if, like in the problem statement, there is clearly stated that each and every element is present in exactly one sequence. So the sequence will be consecutive, like this to this, this to this. No sequence will be overlap. Like the sequence start from one and it end at two, then the second segment would not start from two. The second segment should have to start from three. Okay, so these are the conditions. So if we just find a sum, okay, like a prefix sum, like we find a prefix sum here, and we can just check that for the rest of the segment we find the same sum or not. If we find the same sum before uh, before our length of the array is ended, before we found, before ending all the element, before getting all the element, we found our sum. Then we can also check further that the rest of the element making this sum or not. If this is making, then we can take the maximum length of the segment, which is giving the sum. Okay, so like greedily we can just output the answer. Okay, let's break down another input. So if oh no, yeah, so if we take this segment, we can just start from here and find this prefix is finded further or not. No, this prefix, this 10 is not find. We could not find 10 the rest of the segment. Okay, after that we will try to find the 65. The 65 is present in the rest of the segment or not. Okay, we can find that this is 65. We can see that this element is 65. Then after this we will found the segment is also 65. Then after finding this element, see our segment is not ended. After finding this element, this segment, our segment is not ended. Then we have to find further. Like the further segment is also in the further segment, can we find the same target or not? Okay, so we can very greedily found it. Okay, like in my solution I use recursion. Okay, so just maintain a prefix sum, and for each prefix sum I saving a length. Okay, the length of the prefix sum, that uh, if we are starting from this element 65. Okay, I just saving this length as the maximum length. Okay, of that particular segment for the target, for the target sum. Okay, then then I'm just calling the recursive function. Then in the recursive function we are just calculating that we find the targeted sum or not. If it find, then we are just saving the length of the maximum segment. Okay, if the previous segment is maximum, then the length will be the length same. If this segment is maximum than the previous, the maximum function will uh, generate the maximum, then saving the length. Okay, after that, if the array is left, okay, after the finding the sum, if the array is left, then we are also calling the recursive function one more time and returning here true. If it return true, that if the left array is also generating the same target, then it will return true. Then true and true will return. We finally return true. If so, here if the go or the recursive function generate and positive answer or true, then we can just generate our answer. The minimum of the minimum answer, the maximum length of the of that particular sum. Okay, simply just we can readily find it, and after that we have to just clear the prefix for the next inputs. This is the solution.